All right, 7.1 law of sines. So if I asked you, let's say that's 80 degrees, and let's say that's 20 degrees, and this is x. If I asked you, pause. All right, so if I asked you to find like x, and let's say this is 10, can we find x using SOHCAHTOA? Can I find x right now using SOHCAHTOA? What's different about this triangle? It's not a right triangle. Very good. So law of sines, it's a skill or technique in order to solve triangles that are not right triangles. Okay, so this does not have a 90-degree angle. We cannot use SOHCAHTOA. Tangent is not equal to the opposite, over, adjacent, and so on. So we need a different technique. It's called the law of sines. And if you have sine of A over little a, so large letters, or I guess they're called capital letters, represent angles, and little letters, lowercase letters, represent sides. Sine of A over A is always going to equal the sine of B over B, and it's always going to equal the sine of C over C. That's the law of sines. Some people prefer to flip it. So A over the sine of A equals B over the sine of B. That's equal to C over the sine of C. I'll usually use the top technique. I mean, it doesn't matter, but if you take the reciprocal of it, they're always going to be equal to each other also. So in this problem, what we have is, well, given to us, I'll cross off that, I'll call that A, B, C. Right here, this is considered an angle, side scenario. Angle, side. So the law of sines, angle, side. So that's one way. If we have angle, side, we use the law of sines. Okay? And it's not angle, side, angle, because it goes, if you're going around in a circle, it goes angle, side. So let's say I wanted to find little c, right there. You would do the sine of the angle that we opposite the one we know. We know that's 10, so I'll say sine of 20 is to 10 as, well, we don't know that angle, especially since it's really blurry. Anybody know angle C?
80.
How'd you get 80? And three angles always add up to be 180. Very good. Triangle sum theorem. So this has, well, that's not an 80. The three angles have to add up to be 180. So that must also be, it's actually an isosceles triangle. Okay, so we can say sine of 20 over 10 equals the sine of 80 over little c. So that's an equation. Okay, it's actually proportion. Proportion means it's a ratio equal to a ratio. So we can solve proportions by cross multiplying. So you can go 10 times the sine of 80 equals c times the sine of 20. Now this is just a number, that's just a number. So we're going to rely on our calculators. We do not need to figure out what the sine of 80 is. You don't need to know half angle, double angle, special right triangles. We can actually just ask your calculator. But make sure you're in degrees. So under mode here, mine is in degree already. Just to do one last step before I use a calculator, I'm going to divide each side by the sine of 20. Again, that's just a number. So C is equal to 10 times the sine of 80 divided by sine 20, and we get 28.8 or so. So C is approximately 28.8. Okay, we found how long that side is right there. So if I ask you, or book triangle means that you find everything that you don't have already. We were given an angle, and a side. Now we just found the others, well, C, which is 28.8. We found angle C is 80. So the last thing to find is what? What's the last thing I need to know on this triangle? Yeah, side A. So why don't you try to find side A given this information? Oh, because it's isosceles. Well, support your answer with the law of sines. You should get 28.8. See if you can find it using the law of sines. You're so smart. So we for sure need to know sine of 80 over A. And then if you're wondering which one to choose, it does not matter. So you could do sine of 20 over 10. Or you could have done sine of 80 over 28.8. So cross multiply. So it's literally the same thing right over there. So we get 28.8. All right, does that make sense? All right, so that's an angle side scenario. I might as well give you all of them. So law of sines, angle side. It also solves triangles that are angle scenario. And then we've got side angle scenario. Those are the three situations you use the law of sines. If you have a side angle side or a side side, we just can't use the law of sines. We'll use the law of cosines, which we'll do in the next section. But for law of sines, these are the three that we did. We just did an angle side, so might as well try an angle side angle here. All right, so let's say I've got an angle side angle. Here's my triangle. Let's say that's 70, and this is 8, and we'll call this 40. All right. So see if you can, let's just find let's see if you can find little a. I named my horse Mayo. Sometimes mayonnaise.
I hope everybody who watches this video hears the dead silence from that joke.
They are, to my audience, my students right now are hyperventilating from laughter. They still have not come up for air. They're kicking and screaming on, okay, they're not screaming, so. Well, there are two people that nodded their head just to at least acknowledge that it was an attempt at humor. It's not bad. I mean, it's better if you see the way it's spelled. Mayonnaise.
It's not funny, but it's clever. Yeah.
Clever, not funny. All right, I'll take it. So first thing we have to do is what? Good. We need to find angle C. So 180. Let's see. Is that another? You gotta be kidding me. I'm better than that. All right. So sine of 70 over 8 equals the sine of 40 over A. So now we can cross multiply. 8 times the sine of 40 equals A times the sine of 70. Divide by sine of 70. I don't know what I'm doing. You can change that into a 7 and cross that off. No big deal. So we have 8 sine 40 over sine. Let's see. 8 sine 70, 8 sine 40 divided by sine 7. I'm rattled after all that humor. A is about 5.47 or so. How many got that? Raise your hand. Nice. All right, a little bit better than verifying identities. Okay, so those are the first two scenarios. This is an angle, side, angle scenario. So the first one was angle, angle, side. Now we have an angle, side, angle. The third one is the trickiest. Okay, it's the side, side, angle. We don't want to spell that the other way because we're way too mature for that. But let's say I have angle A is equal to 40 degrees. Let's say A is 6 and B is 10. And for the side-side angle, there's actually three scenarios. A side-side angle could have 0, 1, or 2 triangles. Okay, it's possible you don't have any triangles given the information. Sometimes you only have one, and sometimes you can actually form 2 triangles given the information. So I'll show you how to determine that out. Okay, so we'll start by making our drawing. Doesn't matter. I'll say A is 40 degrees, little a is 6. I'll call that one B and this one C. So that means little b is 10. Okay, so we have a side-side angle scenario. All right, so we know that we're going to do sine of 40 over 6 equals, well, we have to do angle B, so sine of B over 10. So far, so good? Okay, so we're solving for B here, so we got to get rid of that 10, so I'm going to multiply by 10. So I have 10 sine 40 over 6 equals the sine of B. What is 10 sine 40 over 6? 10 sine 40 divided by 6 equals. All right, so we get 1.07. Sine of B is about 1.07. How do I figure out what B is if I have a number equal to the sine of? Very good, inverse sine. So everybody figure out what the inverse sine of 1.07 is. Hit second sine, 1.07, and what's your calculator tell you? Inverse sine of 1.07, the second sine of 1.07. It's yelling at you, isn't it?
Yeah, it's something's wrong.
Why would that be? What angle has a sine of 1.07? You remember the graph of sine? When will it be 1.07?
No.
What's the highest it could be? 1. It'll never be 1.07. It'll never be below -1. So it's impossible to have an angle that has a sine 1.07. Okay? So what's our answer? Does not exist. So there is no triangle that has this as your criteria. It just doesn't exist. Okay, so that's one possibility. 0 triangles. We'll do another one. Let's say I've got angle A equals 20. Let's say A is 5 and C is 10. See how far you can get with that one. I'm going to draw a little sketch. I mean, it shouldn't, normally I just draw any triangle, any shape, but I'm going to intentionally make this angle A a pretty acute angle. So let's go like this. I'll go A, which is 20, and this is 5, and B and C, which is 10. So this is a side-side angle scenario. Go ahead and make some progress on that one, and I'll join you in a second. Okay, so sine of 20 over 5 equals the sine of c over 10. I'm going to multiply by 10, so 10 sine 20 over 5 equals the sine of c. 10 sine 20 divided by 5. Okay, we have a number between -1 and 1, so we know it exists. So we're going to do the inverse sine, second sine, of that answer. So I do second sine, and rather than retyping it, I'm just going to hit my answer button, which is right down here. So I'm going to hit second answer, and we get 43.16. All right, so C is about 43.16. So far, so good? Yeah.
My calculator's
Giving you different answers?
Yeah.
So are you in degrees? Did you check? Hit mode and see if you're in degrees or radians, because if it's in radians, it's a mess. You're in radians?
Yeah.
Okay. All right, so 43.16. So nothing different about what we've done so far. Now, if I asked you back last chapter, and I asked you to find sine x equals 1/2. Okay, where is sine equal to 1/2? What quadrants is sine equal to 1/2 in? I know that you didn't want to hear the word quadrant again, but where is sine positive? Yeah, top two, right? So sine is 1/2 right there and right there. So there are two answers for when sine is equal to 1/2. This one, which is 30 degrees, and then the other one, which is, what's my other angle? If this is 30 degrees, what's my other angle going to be? 150 degrees. The easiest way to get that is 30 degrees and then 180 minus 30 gives you 150. So 30 degrees and 150 degrees. Those are the two times that sine is equal to 1/2. So up here, I had sine C equals 0.68. Well, how many times is sine equal to 0.68? It's actually almost 1/2 what I had down here. It happens twice. It happens in this quadrant, which is 43.16 degrees. And what's my other angle going to be? Whatever 180 minus 43.16 is, right? So I've got one angle. Now I'm going to do 180 minus that answer, and it gives us 136.84. 136.84. So C is 43.16, or C could be 136.84. Okay, we actually have two answers for C. Now we still don't know if we have a second triangle. We got two answers for C. Is it possible that we would have a triangle that has 136.84, 20? Do we still have enough angle to go around to make 180? If this is 136.84.
Yes.
Right, because this is 136 plus another 20, we're at 156.84. So we could make, imagine this side right here is actually hinged. There's a hinge right there, and you move it this direction right there. That's still 5, that's still 10, and that's 20. This angle would then be 136.84, and then we could figure out B. There's two ways of drawing the same triangle, and it works. So, how do you answer the question? We're going to keep going on this side right here as if C is 43.16. Finish the whole triangle knowing that C is 43.16. If that's 43.16, the angle B would be 180 minus 43.16 minus 20. You get B, and then you do one more law of sines and you're done. Okay? On this side, we know that angle A is 20. That was given to us. So we know that angle B we're going to find. Angle C we're going to find. A, B, C. Okay, what else is given to us? We have C is 10, and we have A is 5. Those are the three givens. Under this scenario, C could also be 136.84. Then we could do 180 minus that, minus another 20. So B would be 23.16. And then you could do the law of sines one last time. Sine of 23.16 over B equals the sine of 20 over 5. And then you can find our side. So once you do the inverse sine, you get two scenarios for C. Chop it up into two different triangles so you don't get all mixed up. The last, how do I know if the second triangle exists? If we have enough angle to go around. We could have gotten, like, if we got 170 degrees for C, 170 plus 20, we're already at 190, it would be impossible to have a second triangle. All right, we have just a couple minutes. I'll give you one scenario where you only have one triangle, I think, if I made this up all right. So B is 100, B is 58, and A is 13. All right, so 100 degrees, a little bit bigger than 90. Call that BAC. That's 100, 58, and A is 13. We have a side-side angle scenario. I'll just kind of go through it. I know that you could do it, but I'm just going to show you. So let's see. We got sine of 100 over 58 equals the sine of A over 13. By 13, so 13 sine 100 over 58 equals the sine of A. 13 sine, well, let's see, 13 sine 100 divided by 58 equals 0.22. So sine A equals 0.22, and I'll do inverse sine, and I get 12.75. So A equals 12.75. That's one option for A. The other option for A would be 180 minus that, which is 167.24. Okay, we're going to have another triangle that has 167 degrees plus the 100 degrees. We're way beyond 180. So the second triangle is not going to work here. So you would just move forward knowing that A is 12.75 degrees, and you can finish the triangle. So you could have 0, 1, or 2 for the side-side angle. That's the toughest part of this section. Otherwise, it's law of sines.